Hello and welcome to all. In previous session, we have discussed about the first law of motion, in which we understand about the definition of force and inertia of rest and inertia of motion. We have also discussed about the practical application of first law of motion in our daily life. Now, today we will discuss about the Newton's second law of motion. It states that the acceleration produced in a body of a given mass is directly proportional to the applied force on it. That is, the acceleration here A represents the acceleration and F represents the force. Here, acceleration produced in a given mass is directly proportional to the applied force on the body. And the force needed to produce a given acceleration in a body is directly proportional to the mass of the body. That is, F is directly proportional to m. From these two statements, we conclude that F will be equal to ma. From the last session, we have able to understand that the force, basically the force is an external agent which is required to change the state of rest or a state of motion, or try to change the state of the body. And it is the amount of force is varied according to mass of the body. If mass is larger, then required force to change the state of the body will also be large. Here, this is the F equal to ma. This is the relation for second law of motion, and the second law gives equation of motion. The SI unit of force is Newton, which is represented with capital N, and 1 Newton is the force which, when acts on a body of mass 1 kg, produces an acceleration of 1 meter per second square. Therefore, 1 Newton will be equal to 1 kg into 1 meter per second square, and the unit of force in CGS system, the unit is dyne, and 1 Newton is equal to 10 to the power 5 dyne. Now we have to understand the Newton's second law in terms of rate of change of momentum. In previous lecture, we have discussed about the term linear momentum, or momentum simply, which is represented by P. It is the product of mass and velocity of the object. And also we discussed about the change in momentum, which is the change in velocity, represented like delta p is equal to m into delta v. Now, the representation of Newton's second law in terms of change in momentum: the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Thus, if under the action of force F, thus If under the action of a force F, this is the external force, for time interval delta t, the velocity of a body of mass m, the mass of body m changes from initial velocity v to v plus delta v. This is the initial velocity and this is the final velocity of the object, v plus delta v, and its linear momentum, initial linear momentum, which is represented here pi. Pi represent the initial momentum, which is equal to m into v, mass into initial velocity, and final momentum of the object or the body will be equal to mass into final velocity. Final velocity is v plus delta v. This is the initial momentum, this is the final momentum. Then the Newton's second law represented as F is directly proportional to the rate of change of momentum, that is delta p upon delta t, or this can be written as F equal to k into delta p upon delta t, where k is the proportionality constant, and it will be equal to 1 k is the proportionality constant which is equal to 1. Then the force can be expressed as F equal to delta p upon delta t. As we have seen that F equal to ma and F equal to change in momentum with respect to time, then we can conclude that F is rate of change of momentum, that is delta p upon delta t, is equal to ma. This is the final expression for second law of motion, and some important points are related to the second law of motion. The first point is this: in second law, if F equal to 0, it implies that A is also 0, the acceleration will be 0. Here the second law is obviously consistent with the first law. In first law we have discussed about if the net force is 0, then the object is in rest condition or it moves with uniform velocity, that is acceleration will be 0. This point follows the first law of motion. And second point is it is a vector law. It means that if the relation of F equal to ma can be expressed as like this: force is a vector quantity and acceleration is always a vector quantity. The acceleration will be in the direction of the net applied force. Therefore this is a vector law. It means that if we want to express the second law of motion in the three axes of a coordinate system, we can say that force in x direction will be equal to mass into acceleration in x direction of the particle, and force in y direction will be equal to mass into acceleration in y direction of the particle, and force in z direction will be equal to mass into acceleration in z direction of the particle. And the final, for final we can write here this is equal to fx square plus fy square plus fz square. And the third point is the second law of motion is applicable to a single point particle. That is, the object is supposed to be a point object or single point object. In the relation of second law of motion F equal to ma, here F is the net external force on the particle and the A stands for acceleration of the particle in the direction of net force. This is an object placed on a horizontal plane having mass m, and it consisted various it is composed of various particle of mass m1, m2, m3 like that. Then and the object is moves in forward direction with acceleration a. Then we can say that the acceleration of the each constituent particle of the object is in forward direction with acceleration a. All particle moves in forward direction with acceleration a. Now we will discuss about the Newton's third law of motion. It states that to every reaction there is an equal and there is to every action, sorry, it will be to every action there is an equal and opposite reaction. In an interaction of two bodies, no, in an interaction of two bodies, there are action and reaction forces present. The action and reaction forces act on two different bodies which are in physical contact. Here, an object of mass m is placed on a horizontal table or horizontal plane. The weight of the object is acted downward, which is mg, and the forces applied by the contact surface on the object is in upward direction, which is normal force or normal reaction force, which is in opposite to the weight of the object. Then we can write here the normal force or reaction force is equal to the weight of the object in this condition. Now here the second example in which two balls of different masses m1 and m2, these are in physical contact with each other, that is they are in contact. Then at the contact point or contact plane there is reaction forces acted on these two bodies. The reaction force by m1 or on m2 is represented as r1, and by m2 on m1 is represented by r2. And for equilibrium condition or rest condition, r1 is equal to r2. Here if r1 is action, then r2 will be reaction. Now here is a question related to the second law of motion. Uh, the statement of question is a bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? That is, this is the wooden block. This is the wooden block, and this is the bullet of mass 0.04 kg. That is, m is given 0.04 kg mass of the bullet, and the speed of bullet is, this is the actually initial velocity of the bullet, that is u, which is 90 meter per second. It enters in a heavy wooden block and is stopped after a distance of 60 centimeter. The bullet stopped after this distance, which is 60 centimeter. What is then we have to find out what is the average resistive force exerted by the block on the bullet. Here, the final velocity of the bullet inside the block will be equal to 0, and displacement of bullet inside the block is 60 centimeter. It means 60 upon 100 meter, which is 0.6 meter. Then we have to find out the average resistive force, and from the second law of motion we know that F is equal to external force will be equal to mass into acceleration. Here mass is given 0.04 kg, but acceleration is not given. Then we have to find out initially the acceleration of the bullet in the block. We have the initial velocity of the bullet, final velocity of the bullet, and displacement of bullet in the blocks. Then we have a formula of uniform acceleration. Uniformly accelerated object is v square is equal to u square plus 2as. Here acceleration is negative, that is retardation. Then it can be written as b square equal to u square minus 2as. Here v is 0, then u square will be equal to 2as, and a will be equal to u square upon 2s. U is 90, then 90 square upon 2 into s is 0.6. Now we have to solve this 8100 upon 2 into 0.6, and finally we get that it is equal to 6750, and it is the value of deceleration. Actually we can write here deceleration in negative, then deceleration will be equal to minus 6750 meter per second square, and the average resistive force will be equal to mass into acceleration. Mass is 0.04 kg and deceleration is 6750 meter per second square. Finally we got that the resistive force will be equal to 270 Newton. That's all. Thank you.